coefficient of restitution, a lot of people like to say that it is the bounciness of an item, but rather Newton's law of restitution states when two objects collide, their speeds after the collision depend on the material that they are made of.
Now, Newton's law of restitution shows us how to find the coefficient of restitution. So, the coefficient of restitution is E, and it's equal to the final velocity of object B minus the final velocity of object A over the initial velocity of object A minus the initial velocity of object B. Now, which object is A and which object is B is completely arbitrary, but make sure when you're using this equation that you're remembering to take direction into account. A way to simplify this equation is to think about both parts of it as the relative final velocity and the relative initial velocity. So if one object is moving away at 4 meters per second and the other one is moving in the same direction at 3 meters per second, their relative velocity is 1 meter per second. Using those same velocities, if both objects are moving towards each other, their relative velocity is 7 meters per second.
See, the coefficient of restitution with one object in regards to a stationary surface is stated coefficient of restitution equals v, which is the speed of the object after impact, divided by u, which is the speed of the object before impact.
Okay, but how can this value actually be used? Do I plug it into an equation or something? No, not really. What it's useful for is determining how elastic a collision is. So, for example, if you have an E of 1, you have a completely elastic collision. Remember, this means no kinetic energy will be lost. This also makes sense because if you have an E of 1, your final relative velocity is the same as your initial relative velocity.
It's important to note that in the case of completely inelastic collision, E will equal 0, and this is where both objects will end up sticking together.
Alright, so now that you have a basic idea of what the coefficient of restitution is, let's work on a question with it. So, a tennis ball with a mass of 0.05 kilograms is thrown at a bowling ball with a mass of 7 kilograms. It has an initial velocity of 4 meters per second. Now, this same tennis ball is thrown at a basketball with a mass of 0.5 kilograms at the same initial velocity, and it rebounds with a velocity of 3 meters per second. The basketball has a new velocity of 1 meter per second, and the bowling ball has a new velocity of 2 meters per second. Compare the coefficients of restitution here and determine which one is higher. Alright, if you need a hint to help you out here, one thing that I'd consider is what variables do you actually need in this equation? There's quite a few that might not be necessary. Alright, hopefully you got A as your answer. So the coefficient of restitution would be higher with the basketball. Now, why is that? Well, it's just a matter of finding the ratios between relative velocities. Remember, mass doesn't matter when we're calculating the coefficient of restitution, but something else does. So, something important in this problem is looking at direction. Because the bowling ball and tennis ball are moving away from each other, we have a fraction of 3 over 4, not negative 1 over 4.
So here's a poll question I want you guys to think about. A tennis ball is dropped from a height of 10 meters, and again from a height of 5 meters from the same building onto the same surface. What collision will have a larger coefficient of restitution? Is it A, higher for 10-meter building, B, higher for the 5-meter, C, same for both, D, need more information? The correct answer is C. It's the same for both of them. Why might that be? Assuming that other factors are constant, like the type of surface the ball bounces on, the coefficient of restitution will be the same for both cases because it depends on the properties of the colliding objects, not the height from which they fall. Therefore, the height of the building, 10 meters or 5 meters, would not affect the coefficient of restitution in this scenario.
Alright, here's one final problem for you. A tennis ball strikes a smooth wall with a velocity of 20 meters per second. The coefficient of restitution between the ball and the wall is E is equal to 0.75. Find the velocity of the ball just after impact. Alright, in order to solve this problem, we'll need the theorem of conservation of momentum. we'll also be using the coefficient of restitution. Finally, we'll be using components of x and y. First, we can use momentum theorem to find the speed in the y direction of the ball after impact. Next, we can use the coefficient of restitution theorem to find the speed of the ball in the x direction after impact. Finally, using our components, we can combine these two to find the final speed after impact.